Hi, my name is Bandan, and this is a talk about Qemu MTP implementation. Most of the initial work was actually done by Gerd, and I added a few more features, and we have an intern who just finished. So this is a quick update on what's the current status. So it's been around for a while, and I believe that there hasn't been a lot of testing. A lot of people are not aware of it. So I thought this would be a good way to be a short introduction to the topic. So to start with, the first thing is, when we have a case where we have to share a folder between the guest and the host, there are many ways you can do that with Qemu. And owing to the use case, inevitably we always use think of network-based solutions like NFS or SSH, FS, Samba. There are also device-based solutions which are on top of VirtIO, like 9pfs VirtIO Serial, and then last forum there was a talk on VSOC. You can actually build these on top of VSOC. So USB-MTP is also a device-based solution, which is on top of the USB layer in Qemu, so each one of them have each one of them have their own advantages and disadvantages. With network, the interface could be different between the host and the guest, so you know that the firewall can always kind of be a problem. But the good thing about network-based solutions like NFS is that it's more prevalent, it's everywhere, so it's easy to set up. With device-based solutions, the problem is there could be a situation where you don't have a client front end for whatever you're trying to achieve. So USB-MTP talk is meant as kind of another solution to this problem for which we have so many options. It's not meant to be the best, because I know it's not the best. It's just another option that you can think of and probably use in certain use cases. So whether more options is good is actually not the point of this discussion. So just a quick introduction. So MTP was an extension to PTP, which is Picture Transfer Protocol, that came upon because most of the camera manufacturers, they were using their own proprietary formats to share pictures between the camera device and the computer. So there was this common standard so that the camera manufacturers don't have to expose their file system internals and yet be able to easily transfer file images through a USB. So an MTP is just an extension to it, so that you can actually, that applies to just not images, but rather all kinds of binary files. And we have new names here. So the client is called the initiator, and the server is called the responder. And in terms of if you consider like a mobile phone and a computer, so the initiator is the computer and the cell phone is the responder. And the reason they're called that way is because the responder or the cell phone cannot initiate a USB-MTP, any kind of USB-MTP transaction on its own. It cannot advertise whatever features it has, properties it has. The initiator or the host computer has to kind of initiate the transaction saying that I want this file or I want information about this file. So, and that's why they are named such. And one important point to note about MTP is that all operations are atomic. So if you initiate a write, for example, the server is going to finish that write before it can do anything else. So it's one operation at a time. And some other features or disadvantages rather are it has limited file system support. But it manages to get the thing done. It has read, modify, copy, move, delete, but it does not have direct write, so you have to copy it over to your temporary location and then edit it and copy it back. It can be on top of many transport layers, like the spec doesn't say exactly what kind of transport to use. You could just use anything as long as there's some certain requirements are met. But there are USB media MTP devices. It's a recognized device class, so it's more common on USB transport. So owing to the way it is, so MTP is a server-controlled file system, if you will think of. So it supports DRM, and because the server has control over what kind of files to and how much of the files to transfer to the initiator. So it supports DRM, and I actually think Windows Media Player actually uses MTP for enforcing DRM. I mean, I'm not sure. I don't use Windows. And but it's the standard. It's pretty much the default in Android, though, because I have a later slide which explains the reasoning. But it's of course very common in Windows because even an old version of Windows is going to work with MTP. And with Linux, I think any recent file manager that is should be basically plug and play. It should not be a lot of effort. So this brings us to the other common way to share a USB device, which is USB mass storage, or UMS. So the advantage of MTP over UMS is that with MTP, as we mentioned before, the storage is in control of the device. So there could be a possibility, but the chances are minimal that the computer with which you are sharing a folder is able to corrupt your file system in your share. This is because the server has control over what kind of changes to do to the file system, and if it can actually reject a change that it thinks is not nice for itself. And as I mentioned, Android used to use UMS before, and then what used to happen was all the OEMs, they used to have partitions, and they used to only expose two, which is, for example, video. Just an example. Videos and pictures, they used to assign lots of spaces for videos and pictures, but they did not assign a lot of space for applications, data, or whatever the system folders are. So you would end up with a phone where you have like 16 gigs of space for images and videos, but no space for applications. So you'll pretty much be full very soon if you install a lot of applications. So to take care of that, they made MTP the default. And an interesting side effect of that was, at that point, I think they were trying to use ext3 as the file system on the phone, and they were being forced to use VFAT because every system out there was Windows. So this is a high-level workflow of what happens when you plug in a MTP device. And doesn't necessarily just apply to Qemu, but it's most kind of a generic. So when you connect an MTP device, the USB core in the system or the host computer finds out that the MTP device is connected, and this is USB transport layer dependent. The device descriptors show that this is an MTP device, and then at that point, the system can decide what to do with it. It can either just ignore or just let it sit, or it can ask to open a session, request device features, capabilities, names, what are the file contents, and in response to that, the MTP device can then send an array of integers, which are basically object handles, which point to the contents of the shared folder. And the initiator or the host computer can then also request specific information about these object handles, and this goes on, and the device sends back metadata, the file name, the file size, the file format, for example, and then the actual exchange request can happen when the initiator decides that it needs a specific object handle, and then it sends that object ID back to the MTP device, and the data transfer takes place. So with respect to Qemu, everything that we discussed in the last few slides applies. And I'm sorry, the font size of the code section is too small. I tried to increase it, I could not. So that's a very minimal user scenario where you can just define a device USB-MTP and specify an X route which is the shared folder, and you can describe it with a name. And the same thing applies. It's one file operation at a time. It supports file changes from the host in the guest. Basically, the guest can see what kind of changes have happened to your file based on iNotify, which is Linux-centric. And it supports greater than 4 gig files. And that is interesting because the size field in the structure is actually 32 bits. So they have a way to transfer more than 4 gigs. And of course, the most important part that's missing right now is it's not exactly write support, but rather changing an object that is in the share by the client or the initiator. And that was partially being done as part of the the internship that we had, outreach internship that we had. So since MTP runs on top of USB, this is a quick primer on USB, although I don't know much about USB. I think this is just a basic understanding of what you need to know so that you can understand how MTP works. So basically, the communication in USB happens through endpoints. So there are 2 main endpoints that we need to care about, and there are in, which is basically from the device to the host or the responder to the initiator, and the out, which is basically the opposite way. And as far as the types are concerned, there's control and there's bulk, which is the one that we are most concerned about because that's being used to transfer the actual data in the files. And there's an interrupt endpoint, which we use to actually implement the file notification changes that I just showed in the last slide. The control endpoint is something I don't think we use because that's mostly used by the USB, the USB core to probe the device and recognize its abilities and all that stuff. I don't think MTP actually uses it for anything. So with that, this is a quick look at the data structures we have. First of all, any type of transaction that we have in MTP is associated with a session. So the moment you kind of open an MTP share, a session is created. And that thing is associated with the MTP struct. Now, most of the important fields over there are the USB device, and we have MTP data. And there's data in and there's data out. So data in is basically, it's confusing, but data in basically means from the responder to the initiator or from Qemu to the guest, and data out means from the guest to the host. So if there's any data that needs to be sent from the responder to the guest, then the data in field is used and the data out is the opposite direction. Now, the situation where data out would be used is, for example, the client actually makes a change to the object. So it can fill up the data out structure and then send it to the responder. And since we don't have write support right now, so that's pretty typically just unused right now. MTP control is just it's a generic structure to either send a command and also get the status of a command. In this context, it's basically used by the responder to send back the status of a command or a query that the initiator initiated. The config iNotify part is there's an iNotify FD, which is the notification FD for file change monitoring, and there's a list of events that we keep sending when the host asks for it. The other important data structure is MTP Object, which is basically the one that actually defines the contents of the file. So the most important part is the handle, which is the integer ID that I spoke about, because that actually signifies the contents. And there are other fields, but that's the one that the initiator is going to use to request the contents of a file. And finally, as far as the interaction between USB and MTP is concerned, this is the hook. USB-MTP handle data. So there are 3 cases. Basically, data in is when there are responses from the MTP device or Qemu that needs to be sent out. That's where they get filled up with the MTP data structure, and then they get sent out. If there is a request from the host, then the data out case is the one that the code looks for. it gets the USB packet, formats the MTP control structure, and gets whatever request the guest has regarding MTP, and then processes it, and then waits for the next EP data in event. And as far as file changes are concerned, that's the case where if the case reaches there, then and the Qemu MTP implementation is going to check for if there are any pending events as far as file changes are concerned, and then it's going to send out to the host. So with that in mind, so there are 4 major sections in MTP. First of all, there's object enumeration, there's notification changes, there's the actual data transfer, and then there's file operations so write does not exactly is write, but rather the copy, delete, move, those file operations. So let's quickly go through them one by one. As far as object enumeration is concerned, when the device is connected and the initiator wants the list of files or whatever objects, if you will, in the shared space, it sets up a MTP control packet with this specific field set to 0 or all Fs, which basically means that try iterating through starting from the root of the share, go through all the folders and find out what files and folders I have. And then it fills up that control packet and then sends cmd get object handles, which is the command that is used to get the list of list of objects. And the responder or the Qemu implementation of MTP is going to do some sanity checks, and then it does a readdir standard system call on the shared folder that we have. And then as it goes through each of the files and folders, it fills up MTP object structures at that time, and recursively. And then once it's all completely done, and then it will take a MTP data struct and then fill it up with integer 32 handles and send it back to the initiator. And at that point, the initiator has a list of integer values which correspond to the file names, not really the file names, but the files and the objects in the share. It can actually just use that integer value to request contents of a file, but that's completely useless, right? So you have to use the next command, which is cmd get object info based on this specific integer value. You could fill up a new MTP control packet and then send a get object info in the response to which will be the name of the file, the size of the file, the format, and some other information, and that can help the initiator decide if this is a file I want, if it's going to be too big for me, if this is a format that I don't support. And once it's done with that, it can then decide to actually get the file contents through cmd get object. The amount of data that the responder can send is limited by the size of the USB packet, but the responder is going to keep track of the offset at the last offset that it left off at. And and the next time it starts up the second offset and fills up a new packet and sends it over, and this way the whole file is transferred. The next thing is the notifications. So usually we know that if any device needs servicing, it interrupts the host. But with USB, it's actually the opposite. The USB host actually polls the device for events. If there are events need to be serviced, then that's when the host is going to find out. There's no interrupts. And this is the basis for file change notification in the Qemu MTP implementation. It uses iNotify, as we just saw in the one of the last slides, which is Linux centric. It works only with Linux hosts, but it will definitely work with any kind of guests as far as there are no bugs. So the way it's implemented is basically when you enumerate the objects in the share, you register watch points for the iNotify handler, and then if a new file is created, you create a new watch point. If a file is changed, you know that it has been an event because you had a watch point on it, and you store these events in a queue. And when the host actually polls this EP endpoint that we saw in the USB hook in the one of the last slides, you get one of the events and send it so that the initiator knows that there has been a change to one of the files. And so so write is, as I keep writing write, but it's not really write. But so there are two steps to making a change to an object on the initiator side or the guest. And it really doesn't matter when the file was created or when it was modified, as long as there are two steps. The first step is send object info, which is basically the initiator has to just do the opposite of what the responder did when it was enumerating objects. So it needs to set up a control packet with the name of the file, the size of the file, the format, and everything else just exactly as the responder would do. And it's going to send it to the responder, and the responder is going to check and make sure that this is a file I can accept. Like the file size is probably very critical. The format is also very critical. And if it sends an OK back to the initiator saying that this is a file I can accept, then the next step is going to be object info, where the responder is going to do the exact same thing that the initiator had done when the guest had asked for a specific file. So basically, if we have to implement write, we have to support both these new commands. And I think as part of the internship, I think the next slide is about that. Yeah, so Isaac Lozano was our outreach intern, and he added support for 4 gig file transfers, which was basically, if you remember, I mentioned that the size of the file structure, the size of the field in the structure is 32 bits. So basically, what you have to do is you have to set it to all Fs. That means that the size of this file is greater than that. And the client is going to know that, yeah, this is I need to keep getting data, and I have to assemble it at my end because the file size is greater than 4 gig. And he also figured out testing MTP on Windows, because that was something that we hadn't tested before. He found out some specific MTP values that Windows was specifically looking for that was actually not mentioned in the spec. And he's also he was halfway through the write support when this all ended. So he did the send object info part, which is basically sending information about the file metadata, rather not the file contents itself. So write support is basically ongoing in that sense. So with that, we have some to-do items. In no way complete, but so the spec says that MTP operations are synchronous, but it also has a section which says that you can also simulate asynchronous operations, where there's a request from the initiator to the responder, and the responder keeps doing the work in the background, and then uses the event endpoint to basically tell the client that the thing is done, and then I'm ready for the next operation. Now, I'm not sure exactly. I'm pretty sure that this needs the help of the client. It's not something that you could just do on your own. So that's something that we could implement to simulate the idea of having multiple operations at the same time, probably along with having support for multiple sessions, where we can actually open up multiple windows for the same share, and then start having different operations at the same time. So the spec says that if there are multiple operations and they are incompatible, the responder should be sending back some kind of an error message. But I think that should not be a problem, because you can just hold off on one of the operations until the next operation, the previous operation, is done, and then you can in this way simulate. And at some point, actually, probably based on the internal implementation of the responder, you can also probably do multiple operations inside the responder and send data back one after the other. So it's not exactly asynchronous, but it could be something that could simulate. This is not something that's in the spec. It's just kind of the ideas that I think of could be next steps. So one of the previous USB slides that Gerd had mentioned that synchronous operations, they utilize a lot of CPU, and that's something that I haven't tried out at this stage. I don't know if that's true or not. So that's a lot of performance audit is missing because a lot of testing is missing, which is the last point. Also, most of the USB work is based on running a Linux guest. So we have to. So I think we know now that it works with Windows because our intern has been working on that primarily. But that's something we need to do to test it out with different guests. And of course, as I mentioned, adding a few more file operations, probably just move or copy is probably enough, but something like delete is also something that could make life more easier. Yeah, and I guess that's pretty much it, if I'm not wrong. Yeah. So, yep, I'm done. Questions? If it's a difficult one, then he will answer it.
Yeah, hi. So I have one question. How does it work when so Qemu is trying to do a file operation because it was told by guests to fetch some file or something. So what happens if for some reason Qemu fails in that operation? Is there a way that you can tell back the guest via MTP protocol or something?
There's definitely a way to notify that an error has happened.
Yeah.
So the guest is going to know that this operation did not complete.
Okay, because I'm thinking of how to expose it in libvirt if we are going to
so I did see some patches on libvirt, but I think they are just there. I didn't see any discussions about them. There's a V3, but I didn't see what happened after that.
Yeah.
And one more thing that Stefan mentioned to me was that there has been issues with some other in another case where since libvirt or Qemu runs as a separate specific user, it does not have permissions to a specific location. So that's also something that I don't know is how it's
the question. Yeah.
Okay. So yeah, I don't know.
Yeah. Okay.
That's something you have to think about.
Okay. Thank you.
Yeah.
I was just wondering about the out-of-the-box Windows support for MTP in the guest. Is it working out of the box with all Windows versions? I've got memories trying that a while ago, and like Windows XP, you needed to install some drivers or something before it worked.
I kind of have a feeling that even with Windows XP, it should just work because it's a USB device and.
Yeah, the USB part is okay. The MTP part.
Oh, the MTP part.
Yeah.
I think you need Windows XP Service 3.
Oh, okay.
Okay, well, you want it for more reason than just MTP anyway, so okay.
And our intern tried it with, I think, Windows 7 and 8 too. So those work, but yeah.
Okay.
Yeah.
Even Windows XP works, but some additional steps. It pops up by default new hardware, and you have to go through this process, but it fetches the right Windows update.
Okay, it can do it automatically.
It's not that big of a problem, but not as smooth as the Windows side.
No, but yeah, what I thought I remember was having to hunt down some binaries somewhere and install it, and then get MTP.
If you have networking, it should even work with Windows XP without too much.
Okay, cool, thanks.
So I just think that I know MTP has a bad rep. No one uses it, but there are good things about it, and I mean you have to admit it.
Several billion Android devices.
Exactly, yeah. I mean, I just spoke to a few more people over here, and every one of them was about how MTP screwed up their device or did something wrong. So,
Thank you.
okay, thanks.